Dear students, let us look at these questions. Both are interesting questions. You can learn some concepts through these two questions. So let us observe these questions. Totally five balls are suspended using separate threads. The pair show electrostatic attraction while some other pair shows electrostatic repulsion. Therefore, ball 1 must be. So here he didn't electrostatic attraction. For example, you take 1, 2. Electrostatic attraction means one is positive, other is negative. Generally, we have this feeling. But repulsion is a sure test. Attraction is not sure test. What is sure test? Here, if it is 1 to repel, both can be positive or both can be negative. But 1 to attract means one is positive. You cannot say two as negative. One positive, two can be either negative or neutral. Right? So we cannot decide. Once you know charge of one body, you cannot decide other charge on other body. That is why repulsion is sure test. Okay. Now let us see. So based on this, this question is framed. Now, since repulsion is sure test, let us start with 4 comma 5. 4 5 shows electrostatic repulsion. Assume 4 as positive. 5 also will be definitely positively charged. Now let us consider charges. We don't know the charges on the balls. Since we assumed 4 as positive, one since these here what is given is these pairs show electrostatic attraction. 4 positive means one can be neutral or negative. We don't know. Actually, what we have to decide charge on the first ball. Okay. 4 positive. These here, these two balls also he is saying attract. Here also there is possibility that two negative or neutral. But he mentioned that 2 comma 3 they repel. Repel is possible, both are positive, both are negative. So neutral is ruled out. So 2 must be negative, right? So now 1 to attract, right? 2 must be negative, means one can be positive or one can be neutral. Suppose if one is positive, then 4 1, here 4 already positive, they repel. But in the statement they given that they attract. So one cannot be positive. Therefore, one must be neutral. So answer is so the nature of charge on the ball one is neutral. Here, next challenge, electrostatic capacitance. What is capacitance of isolated conductor? Assume Earth as spherical conductor. So this is an isolated body. 1 by 4 pi epsilon naught is 9 into 10 power 9. Here it is 1 by 9 into 10 power 9. Radius of the earth is 6,400 kilometers. So which we can write 64 by 9, 10 power minus 9, 763, 7.1 into 10 power. How much you get here? 10 power 5 by 10 power 9. 7.1 into 10 power minus 4. I can write 710 into 10 power minus 6 farads. That is 710 microfarads. But here he given 320, which is wrong option. Second statement, static charge exists on isolated metallic body. For isolated metallic body, charge is integral multiple of E. That means Q must be equal to Ne. So here what he given is Q value 9.6 into 10 power minus 20. Electron charge is this many coulombs. N will be 1.6 into 10 power minus 19. So here N is a fraction. So but N must be integer. So which is contradiction. Such a charge does not exist on isolated metallic body. Second statement also wrong statement. Right. And the next one, statement 3. The work done in moving test charge from the center of uniformly charged solid conducting sphere. Once it is either hollow or solid conducting sphere. Third option I am discussing. Potential at A, potential at B also same. So once work done will be Q times VA minus VB. Since inside solid conducting sphere, potential is constant, VA equal to VB, 0. Work done will be 0. So work done, this is wrong. So what I can conclude is all the statements are completely false.